Hi all. So in this video we'll try to look into the basics of curvilinear motions, which is also referred as projectiles. So before starting with the problems and before starting with the formulas, we'll just learn some basic definitions that goes with the projectile. The first thing is referred as trajectory. Okay. So let me say that you are a person. So at this particular point, a person is throwing a stone, right? So the stone takes this particular path and then it reaches this particular point B. So A is actually the starting point and B is actually the ending point. So your trajectory is basically the path which is starting from A and it travels to the end point B. So your path is basically your trajectory is basically the path that is taken by your object from its starting point till the ending point. Okay. So the next point is velocity of projection. The definition itself will tell you. So once you have this particular projection, it starts from particular point A and then it reaches the point B. So this particular object will be traveling with some velocity throughout this particular path. So that is referred as your velocity of projection. And the next one is called as angle of projection. This might not be explainable in this particular figure. So let me just construct a small figure over here. Fine. So the particle has a point A, which is the starting point, and it also has another point B, which is basically the end point. So the particle is thrown from this particular point, it reaches a height and then it again travels back to the ground, or basically the ending point. So this particular angle that is created is referred as the angle of projection. So this particular theta over here is referred as the angle of projection. Okay. The next terminology is time of flight. So either in this particular figure or in this particular figure, it starts from a particular point, reaches a particular point B. Here also starting point at A and ending point is at B. So there will be a time taken from for the object for starting from A and reaching B. That is referred as your time of flight. The next one is range, which you can find it over here itself. So the distance between your starting point and your end point. So if this particular figure, this is taken as your range. So the distance between the starting point and the end point. Fine. So trajectory, the path from A to B, velocity, how or with what speed the object is moving, angle of projection, the angle that is created from the starting point, time of flight, the time taken by the object for to reach the particular point B, which is basically the end point, and the range is actually the distance between the start point and the end point. Fine. So now we'll get back to the formulas. So before getting into the formulas, just consider this particular figure, and there's a very important terminology that has to be noted down. So if you do consider a particle, so here you have a particle, so this is the starting point and this is the ending point. So this alpha is your projection angle or angle of projection. So this object has a velocity which is inclined, and this is the angle that has been created. So basically what you're doing is, this is a velocity, a vector, and this again will have two components, u cos alpha and v sin alpha. So that is what I have mentioned over here. So v corresponds to the vertical component which is present for that u vector or velocity vector, and your h corresponds to the horizontal component, sorry for the spelling mistake, corresponds to the horizontal component of your velocity. Okay. So your object is prone to have two velocities. One is the horizontal component, another is your vertical component. Please make a note, horizontal component will have u cos of alpha. It's not u sin alpha, it is u cos of alpha, right? Okay, so now we'll just look into the definition or the derivation basically. So alpha, angle of projection, it starts from the particular point O and it ends at particular point B. So P is the path that is taken by the object. So it is going to have two components of velocity, u cos alpha, which is the horizontal component, u sin alpha, which is the vertical component. Fine. So this is what I've mentioned over here. So this again is u cos of alpha. Okay. Sorry. So your vertical component, basically this formula is from this, S is equal to ut plus half at square. So your u over here corresponds to the vertical component. So you're going to have S, since we are talking about the vertical, your S gets replaced by u is equal to, for u you have the vertical component which is u sin alpha, and then you have a term t, okay, and here this a is the acceleration, but here it is against the gravity. So this, let me say that you have a stone and you're throwing it upwards, which is going to have an acceleration but a negative acceleration which is produced because of gravity. So you'll have a minus half g. I'll repeat it. A is the acceleration. Let me assume that you are throwing a stone upwards. It is going to have some sort of acceleration, but most importantly, it is acting against the gravity. So hence you're going to have minus half g, and then again t square is remaining. So this is how the equation is getting formed. When it comes to the horizontal component, is very simple. You're just going to have it as x is equal to u cos alpha into t. This term will not be appearing because this doesn't have any gravitation at all. Okay, this is very simple. Okay, so let me say you're throwing a stone, your vertical component is going to be pulled against your gravity, it is moving against your gravity. When you just take the horizontal component, it is not experiencing any sort of gravity, so this particular component will cancel off. So it is just S is equal to ut, and hence it is u cos alpha into t. Okay, so now what you can do is, just considering the second equation, you can assume that t is equal to x divided by u cos alpha. So this t can be substituted over here and over here. Okay, so from the second equation, t is just taken on one side and all the other terms are brought to the other side, and in the place of t you can substitute this t which you have found from the second equation. So this is what we have done over here. From the second equation, t has been found out, and once the t has been found out, we can substitute it back in the equation, and this is what you're going to get. Finally, you can just simplify it and then you can get the equation. So this is your y component that is present, right? Or basically the distance traveled in the y direction. Okay. So the equation of the projectile, we'll look into the time of flight. So when the particle is at point A, which is basically your, if you go into the previous figure, you'll be able to find that it reaches this end point. Okay, so this is your end point. So this is your point A, which is your end point, right? So if it has to be told figuratively, so you have a starting point O, you're throwing a particular object, it reaches a height, it falls down. So this is your point A, which is your end point, and y is basically the distance over here, over here, over here, right? Here at this particular point A, the value of y is 0. You don't have any vertical distance, so you can substitute in this equation. Hence you will be finding out what is your hence you will be finding out what is the time of your flight. Fine. So the last one is your range of the profile. So it has a starting point, it has an ending point. So this particular slide itself will give you self definition. Your maximum height of the projectile as well as the maximum range of the projectile can be found out. So R corresponds to the range and R max corresponds to the maximum range. Okay. So this corresponds to your range and this corresponds to your maximum range. So this formula is very important when we are trying to solve the problem. And this again is the maximum height. This slide also is again a self-explanatory slide. So put together, these are the equations that you have to remember. What is the time of flight, what is the range, and what is the maximum height that can be reached by your projectile. Apart from that, you have a few set of formulas. If you are able to understand it, it's well and good. So this is again a figurative representation. You can look into the red color dot which is moving. You will be able to find one peculiar thing that is present over here. Basically, your horizontal component of velocity does not change at all throughout your particular projectile. Okay, so it is 60 meter per second start, which is at the starting point, and even when it reaches the end point, you will be able to find that it is again 60 meter per second. Okay, so that is a very important take from this particular slide. Your horizontal component of velocity in a projectile will not change at all. From the starting point to the ending point, it is the same value. Next, we'll get on to the vertical component of the velocity. So as soon as the object is thrown, it moves upwards. It has a positive value. When it reaches a maximum height, it takes a value of 0. See, now it is positive. Now it reaches a maximum height is 0, and after that it drops down, which is going to have a negative sign. So this is the second take. First, initially the vertical velocity will be positive. When it reaches the maximum height, then obviously it is going to have a 0 velocity, and after that it is going to have a negative velocity.